Assalamualaikum warahmatullahi wabarakatuh. Okay, today we discuss about our new chapter number 2. Okay, let me share first my slide. Okay, share the entire screen. Okay, so for chapter number 2, we will discuss about the energy supply and also the energy utilization. So in terms of subtopic, we have 3 subtopics: primary and delivered energy, structure of energy pricing related to electricity supply, and the last one, understanding of electricity billing system and also electricity bills. Okay, so first we go to the primary and also delivered energy. So we try to understand what the meaning of energy consumption and gross domestic product GDP in a simple way. Okay, so what is energy? Energy is the ability to do work. So in order to make sure work or we can do any type of work. So first thing, we need to have ability to do work. Okay, so in terms of period and also location, in terms of human activity, for example, for very early times period, the type of society that involved during that time is gatherers, where at that time human activities, most of them will gather vegetables, nuts, and also wild fruit in order to continue their life. Okay, so if we convert in terms of energy that consumed for the gatherer to conduct any activities to collect vegetable, nuts, and wild fruit, it is estimated that around 2,000 kilocalorie involved during the activity. So this value actually refers to the energy consumed every day per capita. Per capita means for every person. So for every person, average require 2,000 calories in order to conduct the activities to collect vegetable, nuts, and so on. Okay, and during 1 million BC, okay, 1 million years before century. So the in terms of type of society already changed. So now the activity already mixed with hunting and also the gathering. So the gatherer and hunter is considered as the main activities of the society at that time, where they also still continue gathering the wild fruit. But now at this time, the society already know how to hunting the animal to obtain the hunted food, and already know how to cook their food by using what we call the fire. And the amount of energy or energy consumed for each individual at that time approximately around 4,000 kilocalories daily per capita. Yes, you can see that the increase of energy consumption when the activities when the activities of the society, the activity of the human at that time increased. So in year 4000 BC, especially at the Middle East. So in terms of activity, the change. So now most of the human at the time become a farmers. They already know how to grow, plant crops in in terms of greater amount of quantity, and also they know how to keep animals for their foods instead of hunting. Okay, so amount of calorie involved for each person around 12,000 kilocalories. Okay, in 1500 years AD at Europe, they already start to call to introduce agriculture and also small scale industry. Okay, so they can produce more food in terms of vegetable, fruit, and so on. And also they have specialized industry in terms of scale, a very small scale industry. And for sure, the energy that consumed during that time will increase around 20 estimated around 21,000 kilocalorie per person. Okay, in 1900 AD, also at Europe, so they start to have industrialized society where we have where they have large scale industry and produce they can produce mass production in terms of a product from the industry, and around 90,000 kilocalorie consumed per day per each person. And the last one, in 1990 AD in USA, so they already have advanced industrialized society. So they are focused more on consumer goods, consumer society, and they will involve mass transportation in order to what call to distribute the consumer good. So at this time, we will have drastic increase in terms of energy consumption, estimated at 250,000 kilocalories. So if you look at this example for each period of time, so we have the energy consumption and also the product, the domestic product. So that product that produced for the specific activities considered as the gross domestic product. Okay, they obtained by certain activities. So now we will have our certain simple analogy about the meaning of energy consumption and also the gross domestic product, the relation between energy consumption and also gross domestic product. Okay, so in order to describe the relationship between energy consumption and also gross domestic product (GDP), we will use this parameter that we call energy intensity. Energy intensity actually is the ratio of energy used to gross domestic product. And in terms of formula, energy intensity is equal to energy use divided by GDP. So in terms of value, lower ratio value for energy intensity means that less energy is used to produce 1 unit of output. So if the ratio is higher, so the meaning of the higher ratio of energy intensity means higher energy is used to produce 1 unit of output. So in terms of comparison, lower ratio is better because we only use less amount of energy to produce higher amount of GDP. Energy intensity also considered as a measure of an output of an economy with its energy output, as described by the equation of energy intensity, and also a measure of efficiency with which energy is used. For example, if we have a process A that used to produce 1 kilogram of certain product, let's say the process A will use amount of energy around 2000 kilojoule. Process B also will produce the same amount of product but require energy around 5000 kilojoule. So process A is better because the process will use less energy compared to process B. So this will show that process A is more efficient compared to process B. Okay, in terms of manufacturing nation, So the nation or the society that involve a lot with manufacturing, if we calculate the energy intensity, that nation will exhibit very high energy intensity because the nation will consume a lot of energy in order to produce more product, to produce or to increase the production, um, the production. Okay, the threat of global warming. The energy intensity will cause the change in energy consumption and also the change in energy policy. So if we look at the graph shows the trend of energy consumption or energy intensity from year 2000 to year 2021. Okay, so the blue color line, sorry, the blue color data, the light blue color data represent the primary energy intensity. Okay, which is the ratio between energy supply and also GDP. So we can look at the trend reduce, where the ratio of the energy intensity increase, which means it is good because we will use during that time, during the period of time, the energy supply reduce, whether for the industry or for the residential and also industrial sector. So which means less energy supply to produce the same amount of work. Okay, the green color data represent the industrial energy intensity, which means the ratio between the industrial energy consumption for the industry and the industrial GDP, the amount of product produced by the industry. And if you look at the pattern, the value is increased, which means at 2021, more energy consumed by the industry compared to the amount of product produced. The last one is the data for the final energy intensity. So final energy intensity means the energy that the consumption of energy for numbers of sectors in total. So the final energy intensity represents the ratio between the final energy consumption and also the GDP. So you can see the trend of the ratio is decreased. So this trend shows the good indicator for the energy consumption. And the factors that affect the energy intensity are energy price, geographical, technology, and also the fashion and preference. Okay, so these are what I call the explanation or the parameter that used to describe the relationship between the energy consumption and the gross domestic product, GDP. Energy sources, especially in Malaysia, first we have gas and oil. So oil and gas reserve in Malaysia tend to last for another 14 years. And in terms of natural gas reserve rank, Malaysia is at rank 24. And in terms of crude oil reserve rank, Malaysia is at rank 28. So gas and oil we consider as the primary fuel, where this type of fuel will be direct to the customer, and gas and oil also will use at the power plant to generate electricity. Energy source number 2 is electricity. Okay, so electricity generation projection is around 194.70 billion kilowatt per hours in 2024, with an annual growth rate of 5.53% from 2024 to 2028. Electricity source in 2022, fossil fuel contribute around 81%, and the rest 19% actually come from clean sources, with hydropower providing the majority, approximately 70%. And electricity we consider as the secondary fuel. Cost of delivered electricity is much higher compared to the cost to deliver the gas and oil to the customer. Coal. Third one is coal, normally located in remote site, because extracting coal has not been as strong as other energy resources. And in terms of production, coal production increased at 63.1% in 2000 compared to 1995. And also the last one, we have a new energy source that we call renewable energy. And renewable energy such as solar power system, wind power system, is a major role in meeting energy demand needs. So we can use this kind of energy source to top up the typical energy source. And consider a major role in combating global warming. Renewable energy represents 23% of national power, but by the year 2060, it is predicted to reach to 70%. So renewable energy actually is a good way in order to prevent any pollution, because renewable energy approach will not release any CO2, which is good for the environment. Same goes to the nuclear power plant and also the hydropower. However, for the gas, oil, electricity, and coal, all this type of energy source will produce CO2, which is not good to the environment. Okay. So in order to describe the amount of CO2 that releases to surrounding, we have a parameter that we call carbon intensity, which represents the amount of CO2 that is released into the atmosphere for every unit of energy use. And it depends on the type of fuel used for certain process. Okay, for example, if you look in terms of amount of CO2 released for gas energy source will produce less CO2. And if you use oil or petroleum product, the amount of CO2 released will be increased. And the most energy source that release CO2 to the environment is the usage of coal, especially in the power plant. Okay, about primary energy supply. So primary energy supply refer to all type of energy, such as nuclear energy, fossil energy, oil, coal, and natural gas, and renewable energy source, such as wind, solar, geothermal, and also hydropower. Okay, so the graph shows the what we call the amount of energy supply by different type of energy source, such as hydropower and renewable, that represented by green data. Coal and coke represented by light blue data. Natural gas represented by dark blue data. And the last one, the data for crude oil, petroleum products, and others represented by turquoise color data. Okay. So if we look at 2001 in terms of amount of energy supply, so natural gas of course supply energy supply in terms of natural gas is the highest one, followed by the crude oil and petroleum product, and then number 3 coal and coke, and the last one is energy supply come from hydropower and also renewable. However, if we look at the individual value in terms of energy supply in 2021. Okay. You can see slightly increase throughout from 2011 up to 2014. We can see that trend in terms of trend slightly increase in terms of energy supply for all type of energy source. However, after 2015 up to 2021, we can say that the energy supply for all type of energy sources slightly decreased. Okay. So in terms of rank amount of energy supply in 2021, still natural gas is the most type of energy source that supply to our country. The second one is the crude oil, petroleum product, and then the coal and coke, and the last one is still hydropower, renewable energy source. Okay, so these are the trends. Generally, before 2014, the amount of energy supply keep increasing. However, after 2015, we can say that almost constant, and some of the years, the amount of energy supply for specific product slightly decrease. So in terms of rank, number 1, natural gas, number 2, crude oil, and also petroleum product, number 3, coal and coke, and the last one is come from hydropower and renewable energy. So if we look into installed capacity in Malaysia, in terms of the amount of electricity, the installed capacity. So the major component actually come from the natural gas, followed by the coal, because normally this type of energy source will use in called the power station, power generation that produce the electricity. Okay. And energy input in power station, the most actually come from the coal, and then followed by the natural gas. So these two type of energy supply actually the typical energy source that used in power plant, natural gas and also the coal. The structure of energy pricing related to electricity supply. Electricity supply. So in terms of voltage, so we have three category of voltage capacity. We have high voltage, in terms of value between 66 to 500 kilovolt, normally used by energy company, grid company, and also industry, and normally heavy industry. And we have medium voltage, in terms of value 6.6 up to 33 kilovolt, okay, by medium size industry, local energy supplier, and also public utilities. And the last one, the low voltage category, and the value is between 230 up to 400 volt. Okay, used by small industry, local energy supply, public utilities, and also residential. Okay, how call the electricity generate? So in terms of electricity generation, so the electricity actually produced from the power generating plant, such as steam power plant, gas power plant, and so on, where they use coal or diesel or gas or nuclear power as their main energy source. Okay, the electricity also can be produced from the hydro power station, or wind power station, or solar power station. So these all type of power station will produce electricity. So before the electricity distribute to the customer, So by using the what called the transformer, we need to reduce the voltage before arrive at the customer safely. First, we have that transmission grid where what called the power, sorry, the electricity in terms of voltage reduced to 400 kilovolt and transmit to other part of the system through transmission grid. And then we have transformer, or sometimes we call voltage substation, to decrease further the voltage to 275 kilowatt, 275 kilovolt, and reduce again at lower voltage distribution until 132 kilovolt. Okay, and part of the electricity will distribute or transmit to the heavy industry. So in order to make sure that electricity can be used for the small industry, we will have another transformer in order to reduce the voltage from 132 to 33 kilowatt. Okay, so before arrive at the residential, from 33 kilovolt reduced to 11 kilovolt, and before the electricity called used by the residential and also by the commercial building. So we will have another transformer in order to reduce from 11 kilovolt to 240 volt. So these are the how the electricity generation and also distribution. Okay, about electricity tariff. In terms of definition, the tariff is referred to the electricity tariff refer to a payment price list for electricity supply to the customer. And current tariff at this moment is 38.53 cents per kilowatt hours. Pricing structure affected by first by the delivery cost, which is contribute around 10% due to the transmission cost and also intake substation cost. Okay. Intake substation cost refer to the intake substation refer to the cost that involve at the facilities in distribution system, where the function of the substation is to reduce the voltage. So in terms of component, example is such as the transformer and etc. And also we have generation cost contribute around 70%, which is referred to the fuel cost, where gas price is fixed to specific formula and normally reviewed every 6 months. However, for the coal price is determined according to the market price. And the second category under generation cost is the purchase agreement. Depend on the agreement for certain parties. For example, the purchase electricity from the independent power producers. So whatever agreement from the IPP will affect the cost under the generation cost. And the last one, the distribution cost, around 20%, which is referred to the cost involved with distribution substation, how we distribute the electricity, how we distribute to the electricity to the customer, and also involved with the cost for the supply means. Supply means the primary infrastructure or the main distribution line involved. So the cost involved is the primary infrastructure and also the cost involved is main distribution line. Electricity tariff classification, we have numbers of classification. First, we have the domestic tariff, tariff A for domestic, We have commercial tariff, tariff B for low voltage, tariff C1 for medium voltage, which is general commercial, and tariff C2 for medium voltage, considering the peak and also off-peak. The third one, we have industrial tariff, tariff D for low voltage industrial, tariff E1 medium voltage general industry, tariff E2 medium voltage based on peak and also off-peak industrial, and tariff E3 refer to high voltage based on peak and also off-peak industrial. Number 4, under mining sector, so we have tariff F1 low voltage mining, tariff F2 medium voltage general mining, and also we have tariff F3 medium voltage considering the peak and so off-peak mining. And the last one involves agriculture. So for agriculture, we have tariff H1 low voltage specific agriculture, tariff H2 medium voltage general specific agriculture, and the last one the medium voltage peak and also off-peak agriculture. So these are the classification of the electricity tariff based on the sector. Okay, so break for 5 minutes. Let us continue. Okay, just now we already discussed about the electricity tariff classification. So we have 5 types of classification in terms of electricity tariff. So we have domestic, commercial, industrial, mining, also agriculture. So after this, we discuss a little bit, slightly detail in terms of the rate of the tariff for individual classification. Okay, first we discuss about the domestic electricity tariff. So these are the what call the table of electricity tariff under tariff A for domestic. So we have between 0 to 200 kilowatt hours, 21.8 cent, 201 until 300 kilowatt hours, 33.4 cent, 301 until 600 kilowatt hours, 51.6 cents, 601 until 900 kilowatt hours, 54.6 cents, and greater than 901 kilowatt hours, the price will be 57.1 cents per kilowatt hours. Okay, so we can see the increase rate by band. The value, the electric tariff will increase if we use more, if you consume more electricity energy. Okay, the structure of increasing rate actually to promote energy efficiency, so that we will try to manage our energy consumption by using certain approach in terms of energy saving or energy efficiency. Okay, and the lower rate for lifeline band rate, the first 200 kilowatt hours to protect the lower income customer. And the rate for higher band group will reflect cost of service. Okay, so that's why the tariff increase when we use more electric energy. So we will have higher in terms of cost of service that need to faced by the KNB. Okay, commercial electricity. So we have tariff B for low voltage commercial, which is the voltage is around 415 kilovolt. Okay, so we have 1 to 200 kilowatt per hour. Sorry, 1 to 200 kilowatt hours per month. So the rate is 43.5 cents per kilowatt hours. 201 and above, 50.9 cents per kilowatt hours. So the minimum monthly charge for this tariff B is 7 ringgit 20 cents. This type of tariff normally used by the commercial customer. So majority of the customer will have tariff B, considered as tariff B in their electricity bill. Okay, tariff C1 refer to medium voltage for general commercial, and the range, the value of watt, the involved 11 kilowatt, so 11 kilovolt, and also 33 kilovolt. So for each kilowatt of maximum demand per month, so the what we call the commercial, the company need to pay RM 30 ringgit 30 cent per kilowatt. For all kilowatt hours, the rate is 36.5 cent, and the minimum monthly charge under tariff C1 is 600. And also we have tariff C2 for medium voltage based on peak and also off-peak period. So for each kilowatt of maximum demand per month peak period is around 45 ringgit 10 cent per kilowatt. For all kilowatt hours during peak period, 56.5 cent. During off period, 32.4 cent. So the minimum monthly charge, same as tariff C1, which is equal to ringgit Malaysia 600. And tariff C2 normally implement to what I call 24 hours operation customer or company. Industrial electricity tariff. So we have tariff D, normally used by the industrial customer. So we have tariff E1. So tariff D for low voltage, tariff E1 for medium voltage, tariff E2 for medium voltage peak and off peak, and normally applicable for 24 hours operation. And the last one, tariff E3 for high voltage peak off peak industrial. So these are the tariff implement based on the electricity energy usage. Okay. Okay, understanding of electricity billing system and also electricity bills. First, we need to know, before we understand the billing system and also electricity bills, so we need to know the electricity terminology that normally use. First, we have voltage V. In terms of definition, voltage is the difference of electric potential between 2 points. The unit that used for voltage is V volt, which is represent the speed of electron as they pass within a circuit. And the second terminology is current, represented by A symbol. Definition of the current, the rate of flow of electric charge. And the unit that used for current is ampere. E is the base unit that measures the volume of the electron in electrical current. The illustration just to show the relationship between voltage, ampere, and also ohm. Ohm, the unit for the resistance. So the flow of current is depend on the value of voltage, and how fast and the speed of the current also depend on the resistance, which is represented by ohm in terms of unit. Under current, there are two types of current. So we have direct current, DC, the current that remains constant with time, as shown in the figures. The graph shows the constant current direction. Example is the current produced by the batteries. The second one is alternating AC, the alternating current, AEC, a current that varies sinusoidally with time, as shown in the graph. So we have fluctuation of current, positive, negative throughout the time. So the example is electricity produced by the generator. And then we have current phase. There are two types of current phase. First, we have the single phase. For example, in the figure shows the LCD monitor that use a single phase. So a single phase system is one where there is only one AC alternating current voltage source. However, for three phase, such as the electric motor shown in the figures, the three phase refer to the waveform of three supply conductors are offset from one another by 120 degrees. So the figure shows the difference in terms of current fluctuation for one phase and also the three phase current. Okay, then we have power, represented by P symbol. The meaning of power, the rate of doing work. In terms of unit, power will use watt as the unit or joule per second. So this is the base unit that measures the volume of the electron in electrical current. So we have power triangle that describe the power category. So we have different type of power. First, we have real or active power represented by W. Plus with reactive power VAR. So we'll get the resultant in terms of vector apparent power VA. And in between the angle, we have theta. So in terms of formula, power is represent or is equal to voltage RMS multiplied by current RMS multiplied by cos theta. So the theta value represent the angle between apparent power and also active power or real power. RMS stand for root mean square, which means is some sort like average value. So if VRMS some sort like the average voltage, ARMS some sort like average current that occur in the system. And power in the equation refer to the real or active power. VRMS multiplied by ARMS actually refer to the apparent power. Okay, so based on this power triangle, so we can categorize the power into three. First, we have reactive power, VAR, which means in terms of definition is the portion of power that does not transfer energy. The second one, we have real power, W, the work producing part of power. So in terms of formula, if you refer to the single phase, the formula for the real power will be voltage multiplied by current multiplied by PF. PF stands for power factor. And the unit for this formula actually in watt. For three phase current, the formula for the real power or active power equal to square root 3 multiplied by voltage multiplied by current multiplied by power factor. And the last type of power is the apparent power, VA, the product of voltage and also current RMS value, which means VRMS multiplied by ARMS equal to apparent power. Okay, for the single phase, the value will be, so the formula will be voltage multiplied by ampere by the current. For three phase, equal to the apparent power equal to square root 3 multiplied by voltage multiplied by current. Okay, these are three types of power. So the figure shows an analogy represent the power triangle. So we have a boat and also the horse. So a horse considered as active power, providing active power, and the boat in terms of direction will approaching the called the side of the river. And if we tie a rope between the horse and also the boat, so we will have the force that that produce between the horse and the boat is considered as the apparent force. Another analogy, if you take a bag of junk food, which is consisted of chips, number of chips, Reactive power represents the air inside the bag, and the real or true power represents the chips inside the bag. Okay, so the air we cannot use alcohol to produce any work, but the chip, if we eat, we can produce certain work. Okay? And the combination of reactive power and real power will have apparent power. So the more air you have, the higher the percentage of kVAR, the lower your ratio of kW chips to kVA chips plus air. Thus, the lower your power factor. So these are the energy. And we have energy, electricity energy. The definition of electric energy is the utilization of electricity over a period of time. So in terms of the formula for electric energy, unit kWh, kilowatt hours is power, and this power refers to the real power multiplied by time. Okay, other terminology for the electricity is the power factor PF. In terms of definition, the ratio PF power factor is the ratio between the real power and also the apparent power in a circuit. Also can be used as a measure of efficiency of an electrical system. So the formula for PF power factor is equal to real power W divided by apparent power VA, also equal to cos theta. Okay. So for power factor, we have power factor penalty, where TNB will penalize its customer with if the what call if the power factor less than required by TNB. So for example, for the medium voltage user, TNB will penalize if the value of PF lower than 0.85. However, for the higher voltage user, TNB will penalize if the value of PF less than 0.9. Okay. So the customer will get penalty if the minimum value is not achieved based on the value that decided by the TNB. And in terms of calculation, we have two steps. Step number one, 1.5% multiply 0.85, which is called the limit that set by the TNB minus PF divided by 0.01. And we have the second step. If the the current PV less than 0.75, so we need to add for the second step 3% multiplied by 0.75 minus PF, current PF, divided by 0.01. So by the range actually refer to the current, depend on the current value of PF. For example, if the current PF is 0.80, which means in between 0.85 to 0.75. So the formula that involved in the calculation only the first step. Okay. However, if the value of PF is, for example, 0.6, so we need to include both. Step number one, between 0.85 to 0.75, and also step number two, between 0.75 and also the current value of PF. So the reason why can we penalize the customer for the lower value of power factor. First, because we need to pay we paying for wasted power, increase reactive current, and also the increases the total current drawn. The second cause, because TNB need to overcome this negative impact on the power system to deliver this power to its customer. Okay. And the transformer, because the higher usage of the electricity, probably the transformer become inefficient, so we will have additional heat and also the mechanical losses. The last one, the increase of power losses. So the bracket, in bracket, I square R means actually is the formula for the power losses in the line. Result in greater voltage drop across the line, leading to poor voltage regulation. Okay, for example, this is the example of the electricity bill that have the power factor surcharge. Okay, let me look at this calculation example. For example, in the bill we have power factor equal to 0.75. Energy consumption in ringgit Malaysia. So we have two value, 87 ringgit and also 2,174.545 ringgit. So we have two value here because due to the different tariff implemented. Okay. And then if you refer to the power factor surcharge formula, so first we conduct the first step where we have 1.5% multiplied by 0.85 minus 0.75, the current power factor, divided by 0.01, multiply by the actual consumption in terms of ringgit Malaysia, 2261.45. So we get the total of PF surcharge RM 339.22. Okay, suppose we do not need to calculate the second step. However, in order to show you why we only need the first, the first step of the PF surcharge calculation, because the value of PF is the same as the second limit of the power factor for the second step. So you get RM to 0. So in total power factor surcharge will be 339.22. Okay, as shown in the electricity bill. So this is how we calculate the amount of extra charge based on the power factor. Okay, so continue with the power factor penalty. So power factor actually caused by the inductive load like motor source that use ballast. PF power factor change as the load change, and normally we need to keep the power factor less than 1.0, and also the lagging, where the current meaning of lagging is the current lag the voltage. No compensation for overcorrecting PF power factor, thus there is no significant financial benefit in improving the power factor greater than 0.85. Okay, because the company will not get any compensation if increase the efficiency greater than 0.5 or 85%. So that's why there will be no significant financial benefit for the company to increase the power factor greater than 0.85. Low load will require two large capacitor installation, where the capacitor will use to store the capacitor bank will use to store power and also provide it through inductive load when required. Where this capacitor bank will save energy, especially for the energy supplier company. Sometimes we need to install automatic switching equipment to disconnect some of the capacitor to save the energy, so that the capacitor value match the load and also the power factor continuously. By adding the switching, also we add to the cost, the total cost. So these are the actual features of the capacitor bank. So we have the capacitor bank regulator or controller, and this is individual capacitor. So this capacitor will provide power when required, especially for the inductive load, for example, the electric motor. So in order to implement the capacitor bank, so we need to locate, we need to put or install the capacitor at various locations. So there are two types of location of the capacitor. So we have centralized location, central location, most common use. And this type of location, it can improve cost because the connection of high voltage or lower voltage side of the electricity supply, near to the electricity supply. So each unit may need separate switching and does not reduce the current in the internal conductors. So these are the criteria for the central location of capacitor. And also we have individual location, where for this type of location, switch along with the equipment, avoiding the cost of separate switching and also automatic control, and reduce the current in the internal conductors supplying the equipment. So these are the characteristics for the individual location of the capacitor. And for this reason, due to various location of the capacitor, so we need to have power factor correction. Exercise. So you need to calculate the power and also energy, and also identify the percentage of each load and also which load are dimensioned. Exercise 2.2, calculate the active power if the PF and also apparent power are given as in the table. And what is the conclusion from the data obtained? Okay, probably this one is the last one, is about the power factor correction. So in terms of definition, in terms of implementation, power factor improvement or correction is done by installing capacitor in parallel with the load. So this is how we can make the improvement in terms of power factor or the power factor correction. So this is a simple schematic diagram for the system involving two motor and also the utility where we need to supply the electricity. So the first figure is without capacitor. So the blue color represents the reactive power, where the power that not contribute to any work. And we have active power compared to the system with capacitor. So the capacitor will increase the active power by save the electricity in the capacitor. And so we have active power. Okay, so these are the circuit of the inductive load, where the capacitor installed parallel to the inductive load, as shown in the figure. And these are the power triangle illustrating power factor correction. Okay, so we have active power, Q2 represent the reactive power for the first angle, S2 the apparent power, theta then the additional value of reactive power represented by QC after we install the capacitor parallel to the inductive load. And S1 is the new apparent power after the installation of the capacitor. Okay. Okay, so we have total Q1 or total reactive power. So by using the capacitor, we have more value of greater value of apparent power. Okay, now it's about the TNB electricity bill component. So selecting the right tariff can reduce the energy cost of the facility. TNB bill charges. So we have the bill actually affected by the power factor value, the maximum demand, ICPT that is implemented by TNB, Renewable Energy Fund or KWTBV, peak or off-peak rates. So if you look this example of this electricity bill, so we have the consumption of electricity in kilowatt in kilowatt hours, and also the consumption in RM. So we have conduct maximum means the maximum demand, we have ICP, and so we have KWTB, GBB, involved for renewable energy aspect. Example of calculation, for example, from the bill, you want to calculate the unit cost for electricity. So the unit cost of electricity equal to electricity cost Rm divided by total energy use kilowatt hours. Okay, so we have the call the electricity cost per in Rm 102,804.44 cents. Divide with the energy use is 281,656. So we get the rate for the rate in calculating the amount, the total bill in terms of electricity is equal to 0.365 Rm per kilowatt hours. So that's why in the second figures, the bill shows the value of rate of electricity use or rate of tariff rate 0.365. Okay. Multiply with the amount of energy use. Okay, that's all for chapter number 2, part number 1. Okay, Assalamualaikum warahmatullahi wabarakatuh.